Alrighty, this video here is to take a look at a characteristic called standard deviation. This video should be suitable for you if you're in a 3C class. And we're looking at trying to explore this quantitative characteristic, meaning it's associated with a number of one variable data. One variable data is data that we could put into a histogram. So we're looking at standard deviation. We're trying to find out what is it, what it can tell us, and how we can use it. Some prerequisite skills we'll be using here are an understanding of what is a normal distribution, being able to recognize that, and being able to understand what the mean, what the average of a data set is. And first I'd like to take a look at two different data sets right here. We'll be using Desmos. And if we take a look, I have one data set here, a histogram, and another data set that I'll be showing. The first one's in green, the second one is in blue. Now both of these data sets, they have exactly or right about the same mean. The mean is about 4.5 for these two data sets. And we can recognize right away these data sets are spread out a little bit differently. If I were to describe this qualitatively, I would say, well, this blue data set seems to have a lot more values spread around the mean. Again, the mean being 4.5, whereas the green data set has more values that are further away from the mean. I might say that the green data set is more spread out than the blue data set is, even though their means are right about the same. The average of these values, the middle of these values, is right about, right about the same at 4.5. So your standard deviation is going to be a measure of how spread out your data is. And that is, it's going to be a number that we use. And this number, it's going to be a greater number, a bigger number for data that's more spread out. It'll be a smaller number for data that's less spread out. Now, as we're working forward right here, now anytime we have a normal data set, a normally distributed data, then we know our mean will be right smack in the middle. So we can put our mean right there. And the way standard deviation works is we can say, okay, one standard deviation, we'll say 1 SD plus 1 SD from our mean. That's one standard deviation. That's one certain value from our mean. Is further forward, one standard deviation, backwards will be negative 1 SD. Now, what we're looking at is how much of our data is spread out in between plus 1 and minus 1 SD from our mean. That is, and we can see here that's where our peak is because it's our mean, because it's normally distributed data. And because of the way standard deviation works is it will cover 68% of our data will be within one standard deviation of our mean. That is one standard deviation above or one standard deviation below our mean will cover 68% of our data. That's how it's defined. So we're looking for 68% of our data right around our mean, and that's going to give us our standard deviation value. Now, further than one standard deviation, we can go plus 2 standard deviations. We could go down to negative 2 standard deviations from our data. And from there, reaching within 2 standard deviations of our data, we can see it covers even more of our information that we're working with, way more. So we know it's going to be more than 68%. All of this data from there to there, that's going to be almost all of our data. What we're working with, whoops, let's put that back. What we're working with here is 95% of our data is within 2 standard deviations of our mean. And lastly, we can go up to 3 standard deviations, plus 3 standard deviations of our data. We can go down 3 standard deviations of our data, and that covers almost all of our data. It's very, very rare to see any data that's outside of 3 standard deviations because 99.7% of our data is going to be within 3 standard deviations of our mean. That means if we have 100 pieces of data, we're not expecting any values further than 3 standard deviations of our mean. If we had 1,000 pieces of data, 1,000 values that we were working with, we would expect only 3 of them to be outside of this 3 standard deviations of our mean. So how can we use this? Well, let's take a look and we'll work with our first example here. We have 10 test results randomly selected from a math class, and here are the values. Now, we're just going to throw these values right into an online calculator, and we're going to take the mean from that online calculator and the standard deviation. So I'm going to use, actually Desmos can do this for me if I would like. So I can set it up and I can say, let's call this R is going to be our data set right here. It has 10 numbers, and I'm going to use Desmos to calculate the mean of R, which is 70.2. So that tells us that the average of these grades is 70.2, nice and easy. Our mean is 70.2. If I throw that onto our histogram right here, that goes right in the middle, 70.2%, percentages because we're working with grades. Now, what is the standard deviation? I can also use Desmos to find that. STD, standard deviation, and then STDEV with a P. This is just the way you use it on Desmos. You don't have to use Desmos. You could Google your own online calculator for this. And it tells us our standard deviation is, it looks like 9.4. So 9.4 for our standard deviation, we're going to use that to create our histogram right here. All right, so if this is +1 standard deviation, then we're going to add 9.4, which is our standard deviation, to our mean. So I should be working with 79.6 right here, which is +1 standard deviation from our mean. In the other direction, I can subtract 9.4 from my 70.2, 60.8 right here, and that is -1 standard deviation. So what does that tell us? Well, in between 60.8% and 79.6%, that's where we would expect 68% of our data. 68%, yeah, of our marks. So that is right here. That's from 60.8% to 79.6%. That's what we're working with. In order to find in which range 96% of our marks fall, and let's fix that. Really, we're looking at 95% of our marks. We're going to adjust this to add one more standard deviation. So we're working with 79.6, and we're adding, once more, we're adding our standard deviation. That's 9.4. I'm working with 89% on the dot. All right, now further from 60.8, I can head in the other direction, and again, I'm subtracting this time. I'm subtracting our 9.4, and we're going to work with 51.4. So what this means is 2 standard deviations below and 2 standard deviations above, we're working with 95% of our data. That's from a range of 51.4% to 89% right here. Now what about, it's not really 100%, it's 99.7. What about 99.7% of our data? Well, we'll have to go a little bit further. We can see here further than 51.4, we're subtracting another 9.4. We'll work with 42% as our grade. And above 89 over here, we're working with what should be 98.4% of our data. So in which range does 99.7% of our data fall? Well, that's going to be from a 42 grade, 42%, all the way to 98.4. Now, here if I'm asking, okay, which percentage of students got higher than 80%? Well, we can look at that as a 79.6. Okay, what percentage of our students got a mark higher than that? Well, we know, I'll erase some of this right here. We know that this amount of our data, which is which is within 1 standard deviation of our mean, we know that's 68%. So outside of 68%, I have the missing pieces here and here. These 2 missing pieces will be missing whatever 100% minus our 68% that's within here. And we're working with here 32% of our data is outside of this 1 standard deviation of our mean. Half of that is going to be spread on the lower half of which is going to be spread on the upper half. And that's what the question's asking. How many got higher than 80%? Well, I'm going to take a look at this 32%. I'll split that in half. I'll divide it by 2. And I'm working with here 16%. 16% of students would get a mark higher than 80%. So what I want you to do, I want you to take a look at question 2 over here. We're working with a roller coaster. We're working with an average weight of 85 kilograms. An average weight, we can say that's our mean weight, right? And a standard deviation of 16 kilograms. So using those values, I want you to fill out your normal distribution curve here. I encourage you pause the video here and then come back in 5 seconds. In 5 seconds, you'll be able to see what it is we're working with here. Good. Here we're working with our mean right smack in the middle, and then we're going +1 standard deviation, +2 standard deviations, plus another standard deviation, -1, minus another right down here. Now what I want you to do, again, I encourage you, pause the video here, try out questions B, C, and then D. I will throw the answers up here in about 3 seconds. Good, so here we're working with 95% of all of our adults. That's going to be within 2 standard deviations of our mean. We can see that right up here. That's going to be from 53 kilograms to 117 kilograms. Good. With part C right here, what percent of adults are heavier than 117 kilograms? Well, 117 kilograms we know is +2 standard deviations from our mean, so that's going to be 95% of our data is within right here. So we'll take a look and we'll see, well, that means 5% of our data is outside, half of which is going to be above 117, half of which is going to be below 53. We want what's higher than what's above 117, so that's half of our 5%. That's going to be working with 2.5% of our data. And lastly, part D here, we're working between 53 kilograms and 85 kilograms, which is our mean. So that is, we're looking 2 standard deviations below our mean right. 2 standard deviations below our mean, we're looking all of it below. We know 95% of our data is from 53 to 117, but we don't want all of that. We're just looking at half of that. We're looking at the lower half. So that's 95% divided by 2. We're going to work with 42.5% of our data. That's our answer right here. 42.5% of our adults have a weight between 53 kilograms and 85 kilograms. I hope this helped. If you have any questions, please let me know, but you should be ready here to work through the problems, the practice problems for standard deviation.